Although the V2 rocket, more properly known by its A4 designation, was an army rather than a Luftwaffe project, it has a fitting place in this account of Germany's most advanced airborne projects during the Second World War. Rightly regarded as the instrument which gave birth to the modern rocket age and the product of Nazi Germany's largest and most expensive military program, it truly represented the cutting edge of that nation's technology during the conflict. However, Albert Speer, the Third Reich's former Minister for Armaments Production, when reflecting on past events in the quiet of his cell in Spandau prison while serving a 20-year sentence for war crimes, candidly admitted that, notwithstanding the technical brilliance of the A4 program, it was, from a military and industrial point of view, a profound waste of Germany's resources. Having its origins in pre-war research, the program to develop a long-range rocket was to occupy thousands of scientists and army personnel on the secret testing ground at Peenemünde on the Baltic for many years. Progress in the light of the very advanced technical hurdles to be surmounted in the creation of such a new weapon was slow, and early prototypes of the A4 often came to grief. It was on October the 3rd, 1942 that the first successful A4 launch took place from the Test Stand 7 at Peenemünde. The rocket streaked skyward, breaking the sound barrier as it rose, and hurtled out seaward to land 120 miles downrange. Further development and testing continued, with the type becoming increasingly reliable, and even a once skeptical Hitler was coming to view the long-range missile as an operational possibility. In July 1943, with the A4 now viewed as one of the new revenge weapons with which he could strike at England, Hitler committed German industry to a massive program in which he demanded no fewer than 900 of the rockets to be produced monthly. Drawing as it did on valuable metals, electronics, higher engineering skills and masses of labour, the project naturally made severe inroads on other aspects of Germany's war economy at a time when it was hard to put to service the demands for more conventional weapons. The scale of the project drew it to the attention of the SS, and it was under their auspices that a huge underground factory, constructed by and employing slave labour, was built in the mountains at Nordhausen in Germany to mass-produce the V2. Because of the scale of the program, many of the more sophisticated components of the rocket, such as the gyros, control vanes, fuel tanks, and elements of the guidance system, were subcontracted out to specialized manufacturers possessing the necessary skills, and then shipped to the point of assembly for final construction. Integration of the many elements that made up the rocket required a continual process of testing and monitoring to ensure that the completed rocket left the factory equipped, ready for launching. First employment of the V2 came on the afternoon of the 8th of September 1944, when one crashed on Chiswick, one of the suburbs in the west of London. The victims of the 1-ton warhead carried by the rocket included 3 dead and 17 injured. Launch point for the missile was The Hague in Holland. Being a mobile system, it was very difficult to target, and once launched, the rocket was invulnerable to countermeasures. Over the next 7 months, the Germans were to launch 1,054 rockets on London, killing 2,700 people in the process. No Allied military resources were diverted to deal with the weapon, and contrary to Hitler's expectations, had no appreciable impact on the course of the war. What now follows is a detailed presentation of how the rocket was deployed and fired by the launch team. We begin the cycle with a V2 in the final stages of assembly. A technician working on the rear or bottom of the missile uses test equipment to check over the status of the rocket motor prior to the bottom fin section of the rocket body being placed over the power unit. Testing at this stage of the process is vital, as once the body shell is placed over the rocket, it will not be possible for the launch team in the field to get at the internals should there be a problem. Already in the field are elements of the launch team. A heavy-duty Fawn 4x2 Zugmaschinen tows the all-important liquid oxygen fuel container. Another vehicle tows a mobile generator. The Fawn lorry towing the LOX tanker can clearly be recognized by the wisp of oxygen venting off into the air from the rear of the large tank. This small convoy is passing through a village as it makes for the pre-arranged launch site. The V2 was a large piece of equipment and was at its most vulnerable when being moved from its place of assembly and completion to the front by rail. By the time the Germans began their launch of the V2 from The Hague, Allied forces were already in Europe and advancing into Belgium and moving on Holland itself. The whole road and rail network in northern Germany and the Low Countries, still servicing the needs of the Wehrmacht, was under constant surveillance and attack from wide-ranging Allied fighter bombers. It was for this reason that many, if not all, V2s sent to the frontline units were camouflaged to disguise them from the air. Clearly those we are seeing here, being coloured in large sections of black and white, are test rockets, and the film has been made as an exercise for instruction purposes. That notwithstanding, what is seen here is an accurate depiction of the whole process used by all V2 launch teams in their preparation of the rocket, from its arrival at the railhead through to its actual launch, and is therefore characteristic of all launches of the V2 undertaken during the bombardment of London and later still of Antwerp. Using a mobile gantry, the rocket is manhandled by some of its ground crew from the train onto a purpose-built trailer. Of note is the lack of the warhead, which was transported separately from the main rocket body. At a site well away from the railway siding, the rocket armourers take off the seal covering the nose of the V2 and prepare to fit the actual warhead. This is found in its own sealed container section, which is raised up to the nose of the rocket body using a chain and tackle located on another mobile gantry and then offered up to the nose. Great care is taken to align the warhead module with the main body of the rocket before a firm connection is made and the warhead assembly is locked onto the body of the rocket. The warhead weighs 2,150 pounds. Elsewhere, other members of the large V2 crew raise another telescoping trestle. These were standard issue devices and were also employed by the maintenance units attached to panzer formations where they could be used to lift off the turret of a heavy Tiger tank during field repairs. The lifting capacity was about 15 tons. With the warhead now fitted, the Fawn Zugmaschinen pulls the V2 up and underneath the newly raised field gantry. A second Fawn lorry drives up to park alongside the first. It pulls the specialised trailer which is used to carry the now assembled V2 to its launch site and once there raise it so that it can be placed on its pre-sited launch platform. The lifting tackle on the mobile gantry is now used to move the V2 rocket from its rail transport vehicle to the specialized carrying trailer. The slow progress of moving the rocket from one trailer to the other is indicative of the delicacy used by the ground crews in moving the missile. It is important to avoid any damage. Great care is exercised by the crew in locking down the V2 into its carrying cradle. Although empty of fuel, the warhead is now fitted and everything is done to prevent the missile parting from the cradle in the event of an accident. As can be seen, the rocket is securely locked into the framework of the carrying trailer. The rocket is now taken off to the launch site. At the railway halt, another detachment of the crew responsible for the specialized task of fueling the rocket arrives to connect the pump that will enable transfer of the liquid oxygen from the sealed railway container holding the cooled fluid into the mobile container, from whence it will be pulled by lorry to the launch site of the V2. Once all the pipe connections are made, the valves are opened and the transfer of the cooled liquid oxygen begins. The low temperature of the liquid is evident from the white color of the connecting pipes and in the vapor venting off into the air. At the chosen launch site, another Vorn Zugmaschinen pulls a trailer which carries the launching base for the V2. The crew begin the task of setting up the launcher. On each corner of the launch platform is an adjustable telescoping support. They are lowered by crank and placed onto the ground in preparation for the arrival and erection of the rocket. While this particular exercise clearly employs a hard stand, which makes the task easier, in actuality the mobility of the V2 permitted it to employ any fairly level clearing in a forest to launch the rocket. In order to stop the whole edifice from sinking into the ground or toppling over, railway sleepers or lengths of steel girder were placed onto the ground. The crew would then rest the 4 supporting jacks of the launcher on these. Such methods were used in erecting the launchers in The Hague. Prior to raising the rocket, a number of the crew place a special cradle on the nose. This will help in the final adjustment to the warhead just before the V2 is launched. The Milowagen is then winched towards the launching platform by the Fawn towing vehicle. This has parked itself behind the launch platform. Cables are run through to the Milowagen and it's pulled towards the launching pad. Having reversed the trailer so that the base of the rocket faces the launch platform, the Fawn then disconnects itself and leaves it up to the ground crew to literally pull and manhandle the trailer and V2 so that it arrives in exactly the correct position for raising. This process is then carried out employing the hydraulics on the trailer itself. This is a slow process as it's vital that the base of the four fins of the V2 align totally with the bottom of the launching platform. Very slowly the V2 inches up from the horizontal into a near vertical position. Very great care is exercised during this procedure. When the boom operator is certain all is well, the gantry is pulled away, leaving the V2 resting by itself and without support on its launching platform. At this stage of the process, the rocket commander gives the word by radio for the fuel lorries to make their way to the rocket for the next and most dangerous phase of the launch cycle to begin. The gantry is then manhandled away from the standing rocket by the ground crew. They also check that all is well by a quick but expert examination of the rocket and platform. Civilian surveyors attached to the launch team use their theodolites to ensure that the missile is correctly aligned to the vertical, as even a slight deviation could affect the path of the rocket through the air and thus its accuracy. Another member of the crew now arms the warhead. Although fitted earlier, this particular exercise was not carried out. Down below, the mobile generators are brought up to begin powering a number of the rocket's internal systems, such as the turbo pumps, and help in the fueling process, which is due to begin shortly. The fueling pipes are being connected. The liquid oxygen tank on the V2 has a capacity of 12,200 pounds and is mixed with 9,201 pounds of ethyl alcohol and 379 pounds of hydrogen peroxide to enable the rocket to generate the 55,000 pounds of thrust needed to propel it on its journey. Following the liquid oxygen, the last important ingredient is the sodium permanganate, which is added to the lower fuel tank at the bottom of the rocket. The next step is to assemble the igniter, which works on the principle of the Catherine wheel. Activity around the site is now much greater as the time for the launch approaches. As the final adjustments are made to the base of the missile, including checking the motion and alignment of the guidance vanes, all vehicles and other personnel make their way from the scene to take cover. The igniter is placed in the venturi and connected up. The V2 is now ready for launching. The launch is made from within an armoured variant of an 8-ton half-track.
Schlüssel steht, aufschießen. Belüftung klar, Zündung klar, Vorstufe klar.
While of questionable military value, the V2 was undoubtedly a remarkable technical achievement. Perhaps the most fitting epitaph for this most potent of all of Germany's advanced aircraft and rockets were the words spoken by Walter Dornberger to Werner von Braun, the V2's designer, on the day of its first successful launch. Do you realize what we have accomplished today? Today the spaceship was born.